Good morning. All right, so we're going to pick up in section 1.10 today. This is the last section of Unit 1, and so again, the plan right now is to get through the examples in this section today, review on Monday, test will be posted midnight Monday night, and be due Wednesday, 11:59 p.m. midnight, okay? Continue to work on the homework. Definitely let me know if you have questions on that. But otherwise, that's kind of the plan for the next week. And then we'll pick up with Unit 2 once we get through all of Unit 1 in the review. The question from Alexander was, when we take the test, are we allowed to use notes? No. So that's the whole purpose of doing it in Respondus and having to show your environment, showing your workspace on the video is to make sure that you don't have your textbook, you don't have any notes, right? This is supposed to be what do you actually know? And so make sure that you're going through that practice test and understanding what formulas you might need to know, what processes you're going to need to know, because the actual test will be very similar to the practice test. So as long as you know how to do those problems without notes, then you should be fine for the actual test. So the actual test will be the same as the practice test. I believe the first test is 6 questions, if I'm not mistaken. So just know, they will count several points each, right? But there's also partial credit, okay? So just make sure, right, even if you aren't quite sure if your final answer is right, show me as much as you can, show me as many steps as you can, right? So then I can at least give you partial credit for the stuff that is correct, okay? Any other questions? Okay, so remember, this is going to be submitted the same way as that practice tutorial, right? So remember, Respondus tutorial, you have to exit the browser, you'll scan all of your materials, and then you'll upload them using the link that's in Blackboard. So that's why there's a 15-minute window there for you to get out of the browser, use your phone, iPad, whatever, to actually scan and save as a PDF, and then you'll actually upload to the link in Blackboard outside of the Respondus browser. Yeah, so that's the same way that you did the tutorial. So it's going to be the same thing for the test. But again, just make sure I need everything within that 15-minute window. If for some reason you have any issues with scanning or uploading, go ahead and just take pictures and email me your test just so I can tell that you haven't made any changes after you exited the browser, because I have had that issue before. So if that happens, right, and you're like, oh no, the scanning is not working or I can't get it to upload, just take pictures real quick, email me those pictures just so I have proof that you've completed the test and that you haven't changed anything before you do get it to upload. Okay? Any questions? I do not care about the number of pages that it takes, right? So if you need 10 pages to show all your work, that's perfectly fine, right? But that's why I asked that you scan it as a PDF, is so that you can upload a single file and not a whole bunch of image files, right? So that's, take as many pages as you need to, but when you go to scan, make sure that you're saving it as a PDF with all of those pages in a single PDF. And again, those instructions for how to do that are in the Start Here section under alternatives to scanning. So if you don't have like a flatbed scanner at home on your printer, then you can actually use your phone or iPad or tablet or whatever. But there's directions in the Start Here section about how to do that. Okay, so make sure if you haven't done that before, you should have done it in the tutorial, right? But if you still haven't figured out how to save things as a PDF, make sure you go through those steps and make sure you can do it before the test. Okay. So yeah, that's why I said if you do have issues with the scanning, just take pictures and email them to me, right? And that way, as long as I have those within 15 minutes, then I can still give you credit. Okay, but if you go beyond that 15 minutes and I still don't have anything from you at all, okay, then I just have to assume at that point that you're making changes and I have to give you a 0. Okay, so that's why you've got the 15-minute window. But if you have issues, email me, send me pictures, do what you got to do so I can see that you've actually completed the test. Okay. Any other questions? All right. And again, the test is not going to be posted until Monday. So if you think of anything else between now and then, questions about the test or anything, let me know. But we will do the review on Monday also. So you should have a pretty good idea of what to expect on the actual test at that point. Okay. All right. So 1.10, this section is all about lines. Okay. So we're going to look at equations of lines, what that looks like, the slope of a line, all those different things. A lot of this is probably review. Right, but I want to make sure that we go through it. And there is actually at least, I think there's one question on the actual test that pertains to the stuff in this section. Okay. All right. So slope of a line. So the slope M, that's the letter we're going to use to represent slope of a non-vertical line that passes through 2 points, A and B, is going to be represented by this formula. Okay. So we're going to do rise over run, right? So a change in the Y values over a change in the X values. So we're subtracting the y's, subtracting the x's, and dividing them. Notice here, the y's always go on top, the x's always go on the bottom. So when you're doing your slope, just make sure that you're starting with the y values on top. Okay, because that's a common mistake is people want to put the x's up top instead. Okay. Now, if you look at the pictures below here, any line with a positive slope is going to be going up from left to right. And so you can see that in that first graph. A negative slope now will go down from left to right. If you have a zero slope, that means you're going to have a horizontal line. Okay, so any line with a slope of 0 is going to be horizontal. And then a slope that's undefined or no slope is going to actually be a vertical line, right? And that's why this says that we have to have a non-vertical line to be able to use this formula, because if you were to try to do this formula on a vertical line, it's going to be undefined. Okay, positive slope, negative slope, zero slope is horizontal, and then if it's undefined, then you would have a vertical line. All right, so we just want to find the slope of the line that passes through these 2 points, right? So we're just practicing using that formula now. So my first step here is I'm going to label my points. So I'm going to call this first one x1 and y1. And this one over here is going to be x2 and y2. So just remember our slope formula here. We always subtract our y's on top. So we're going to do y2 minus y1 over x2 minus x1. Now, if you had switched your points and called the 8, 5, the x1, y1, and the 2, 1 was x2, y2, it's still going to give you the same slope. Okay, so as long as you label them, right, it doesn't matter which order you label them in, just don't mix up your 1s and 2s, right? You can't call one point x1, y2, that wouldn't work. All right, so in this case, if we start with our y2 value, that's going to be 5. So we're going to have 5 minus, then we're subtracting our y1 value, which is 1. We're going to divide that by x2, which is 8, minus the x1, which is 2. So if we were to simplify that now, what's that going to give us? Good, right? Because this gives us 4 in the numerator, 6 in the denominator. 2 goes into both of those numbers, and so this goes all the way down to 2/3. So our slope for this one is going to be positive 2/3. Any questions on calculating slope here? And that is a formula that you need to have memorized if you don't already know it. Okay, so just make sure that you know your slope formula. All right, now point slope form for the equation of a line. So an equation of a line that passes through a point x1, y1 and has a slope of m can be written this way. Y minus y1 is equal to m times the quantity x minus x1 in parentheses. Okay, so we're basically taking our x1 and y1 values, we're substituting those in here. We're taking our m value, we're substituting it in here. The x and the y just stay x and y, right? Because our linear equation needs to have an x and a y in it, but the x1, y1, and the m all become numerical values. Okay, but this is a formula we can use if we know a point and a slope. We can use our point slope form to write the equation of that line. All right, so we want to find an equation of the line that goes through the point 1, -3 and has a slope of -1/2. So again, our formula here is going to be y minus y1 equals m times x minus x1. Okay, so this time the point that they give us, that's going to represent our x1, y1. The slope that's given here, remember slope is always the m. And so now if I substitute that stuff into my point slope formula, what would that look like? Okay, so yeah, we're going to have y minus a negative 3, right? So that is going to become y plus 3 equals negative 1/2 times x minus the 1. Now, in general, a lot of times they're going to ask you to put this in slope intercept form, right? Which we're going to look at, I think, on the next slide even. Okay, but does anybody remember the form for slope intercept? Good. So y equals mx plus b is what we call slope intercept form. And so if you're asked to put it in that form, then we just need to solve this for y, right? So again, this would be y plus 3 equals, I can distribute the negative 1/2 now. So that's going to give us negative 1/2 x, and then negative 1/2 times negative 1 becomes a positive 1/2. And so then we just need to subtract 3 on both sides to get y by itself. And so what's 1/2 minus 3? Good. Negative 2.5 works. Okay, so if you want to write it that way, or if you prefer fractions, right, this would be y equals negative 1/2 x minus 5 halves. Now, if it doesn't tell you slope intercept form, right, then you could actually just leave it like this right here at this line, right? Because y plus 3 equals negative 1/2 x plus 1/2, perfectly fine. Even if you had the 1/2 factored out, that's fine too. Don't leave a minus a negative though, right? So that minus negative 3, I would want you to change that to a plus 3. Any questions on that one now? All right. So now we want to find the equation of a line that goes through these 2 points, negative 1, 2, and 3, negative 4. So what's the first thing we're going to need to do to be able to find the equation of that line? We got to find the slope. Good, right? So let's use our slope formula here. We can label our points x1, y1, x2, y2. Remember, we always start with our y values on top. So that's going to be negative 4 minus 2 over, and then we're going to do 3 minus negative 1. All right, so if we were to simplify that now, what's that going to give us? Good, right? So negative 6 in the numerator, 3 minus a negative 1 becomes 3 plus 1, so that's 4. And then 2 goes into both of those values, so we can simplify that fraction. It's going to give us negative 3 over 2. All right, so now that we have our m, now if we want the equation of the line, what can we do from there? Okay, good, right? So now we can use that point slope formula because we have a point, we have a slope, and so we can use point slope. So it's going to be y minus y1 equals m times x minus x1. Now, it does not matter which point you use in this case as your x1 and y1. Since I've already labeled the first one as x1, y1, I'll use that one. But just know that if you were to use the 3, -4, that would actually be equivalent to the other equation. Okay, so it doesn't matter which point you choose here. We're going to do y minus 2 equals our slope, -3/2, times x minus, and that's going to be a -1. Now, again, I don't want you to leave minus a negative, so go ahead and change that to a plus. So that's y minus 2 equals -3/2 times x plus 1. That answer right there is perfectly fine if I don't specify slope-intercept, but if it does ask for slope-intercept, then we would want to distribute and move the 2 over. So that's going to give us y minus 2 equals -3/2 x minus 3/2. And then if we add the 2 to both sides, we're going to have y equals -3/2 x. And then if we add 2 to -3/2, what would that give us? It's going to be 1/2. Good, right? So this becomes plus 1/2. Okay, or 0.5 if you prefer that. But in this case, be careful, right? Because it's easy just to see the 1 and think you're going to add 2 to that. We have to distribute that -3/2 first. So we actually have a -3/2 there, and then we're adding 2 to that value, right? And that's how we get 1/2. But again, I would be okay with this answer on a test unless I specifically say slope-intercept. Okay, but if it asks for the slope-intercept form, then you would want to go all the way to here. Okay. I personally use fractions more often, especially when you're dealing with slope and stuff, right? The fractions make more sense because you're actually talking about a rise over a run, and so when you're thinking about graphing, having the fractions makes a lot of sense. In terms of the y-intercept itself, it really doesn't matter, but I personally usually use fractions for that too. But again, they're equivalent, right? So as long as you have an equivalent decimal, you'll still get credit. Any other questions there? All right. So there's your slope-intercept form, right, that we mentioned before. So anytime you've got something in this form, y equals mx plus b, again, the slope is still the m value, right? And this b value right here now represents our y-intercept. Remember, we talked about y-intercepts yesterday in the previous section. So that's where your graph is going to cross the y-axis. Now, the reason this is a useful form is because when you're graphing, it's really nice to just be able to say, okay, where's my y-intercept? And then you can count your slope from there and then sketch the graph of your line, right? So it gives you a pretty good idea of what your line looks like. Whereas point slope, you can still do the same thing, right? But you just have to go find a different point and then plot your slope from that point instead. And again, I know in the homework, a lot of times it's going to ask for slope intercept form. So just make sure you're going to get it down to this form because a lot of times they'll even give you the y equals like out to the side, and then you're just looking for the right hand side of that equation. And so your only option is to move everything to one side. Okay. All right. So now we want to find an equation of a line that has a slope of 3 and a y-intercept of -2. So using that slope-intercept form now, what would the equation of this line look like in slope-intercept form? Perfect, right? So this is just going to be y equals 3x minus 2, because our slope here is 3. That's our m value. The y-intercept is -2. That's our b value. We know slope-intercept form is y equals mx plus b. And so when we substitute in here, we're just going to get a 3x and then a -2 because the y-intercept is a -2. Any questions on that one? All right, now the second one here, we're looking for slope and y-intercept, right? I'm going to rewrite this equation so it's all in one line. So 3y minus 2x equals 1. So what would we need to do with that equation to find the slope and the y-intercept? Good, right? Set it equal to y, get it in slope-intercept form. So our first step is going to be to add the 2x. So when we do that, we're going to get 3y equals a positive 2x plus 1. Right? Now, what do we need to do next if we're trying to get this in slope-intercept form? Divide by the 3. Now, just be careful here. When we divide by 3, we have to divide every single term by 3. So when you go to the other side and divide, make sure you're dividing every term over there by 3 this time. So now we've got y equals, what's 2x over 3 going to be? It's going to be 2/3 x. And then 1 over 3 is just plus 1/3. All right, now we're looking for slope and y-intercept. What's our slope going to be this time? 2/3. Good. And what's our y-intercept going to be? 1/3. Perfect. Okay. So if they ask for slope and y-intercept, just get your line, your equation in slope-intercept form. Then just look for that m and b value, and that'll give you your slope and your y-intercept. Any questions on that now? All right. Now, if we have a vertical line, its equation through a point AB is just going to be x equals a. So basically, we're just looking at what is the x value of the point that we're trying to go through, and we're going to write our equation as x equals that value. Okay, because everything along that vertical line now would have an x value of whatever a is, every single point on that line. Now, if we have a horizontal line that goes through a point AB, then we're going to use the y value, which is b, and we're going to write our equation as y equals b, because that would give us a horizontal line now where every point along that line has a y value of b. So basically, vertical lines, x equals some number. Horizontal lines, y equals some number. All right, so we want to find an equation for the vertical line that goes through the point 3, 5. So what would our equation of a vertical line through 3, 5 look like? Just x equals 3. Good. So we say x equals whatever that x value is of our point. So x equals 3 is the equation of that line. And now the second part here, we want to actually graph the equation x equals 3. So I know I want to be at x equals 3. So this is my x-axis. This is my y-axis. So I'm going to go over positive 3. And then what type of line are we going to have here? It's going to be a vertical line, good, which means it's straight up and down. So now I'm going to graph my line through 3, vertical line. We're going to have a graph that looks like that. And you can can see in this case, right, if you were to go over 3 and up 5 to that point 3.5, 3.5 would be on that vertical line because it has an x value of 3. Any question on the vertical line? All right, now, what about the equation for a horizontal line that goes through 8, -2? Good, y equals -2. This time we want a y equals equation. We want to make sure we're going through that y value, which is -2 this time. So there's our horizontal line. Now we want to sketch the graph. So if we sketch the graph of y equals -2, so where are we going to start this time? Okay, y equals -2, right? So we're going to go down 2 on the y-axis. So 1, 2, there's our -2. What type of line are we going to have this time? Horizontal. This one's going to be left to right, just like this. So this would be our horizontal line, y equals -2. Again, just keep in mind, x equals some number, always going to be a vertical line. Y equals some number, always going to be a horizontal line. Any questions on the vertical and horizontal now? All right. Don't worry about that. Don't worry about that. Parallel lines, okay? You have a screen that you write on. Are you really good at writing with a mouse? No, I have a Surface tablet, and so that's what I'm actually writing on. So I have a pen that I can use to write on that screen. Yeah, so that was one thing when we went fully online that I asked for because I was like, yeah, I need something to be able to write out all these equations and stuff. All right, parallel lines. Okay, so two non-vertical lines are parallel if and only if they have the same slope. Okay, so in this case, if we're looking for, in this case, non-vertical lines, right, because we know vertical lines have no slope at all. Okay, so non-vertical lines are parallel if and only if they have the same slope. So anytime we're looking for parallel lines, we just want to make sure their slopes are the same. Now, what does it mean for something to be parallel? Let's talk about that real quick. Make sure we know what that means. They're never going to intersect, right? Okay, so that's the key here with parallel lines, and that's why if we give them the same slope, they're never going to touch each other, right? And so we can say they're parallel at that point. All right, so now we want to find an equation of a line that goes through the point 5, 2 and is parallel to the line 4x plus 6y plus 5 equals 0. All right, so what's the first thing we're going to want to do here? Good. We need the slope of that equation so that we can use the same slope for the parallel line, right? How are we going to find the slope of that one? Solve for y. Good. Get it in slope-intercept form, then we'll have our slope. So I'm going to move everything to the other side except for the y here. So I'm going to subtract my 4x. I'm also going to subtract the 5, and I'll come over here and do the same thing. So now that's going to leave us with 6y equals -4x minus 5. So then what would my next step be? Good, divide by the 6. And again, just make sure when you do that, we're dividing every single term by 6. So now we have y equals, what's -4x over 6 going to give us? Good, -2/3 x. And then negative 5 over 6 is just negative 5/6. Now, what is it about that line that we care about? The slope, right? So what is the slope of that line? Negative 2/3. All right, so now we know if we're looking for a line that's parallel to that line, then our slope needs to be the same as that line. So we're going to use that same slope now. We need our line to go through the point 5, 2. So what can we do at that point? Point slope formula. Good. So I'm going to do y minus y1 equals m times x minus x1. This is going to be our x1, y1. We have our m, our slope down here. So now we can just substitute everything in. So what's that going to look like if we plug everything into that formula? Okay, y minus 2, good, equals negative 2/3 is our slope, and then times x minus 5. Perfect. Okay. And again, if it doesn't specify what form, right, then we can leave it just like that because that's an equation of the line that goes through that point and is parallel to the other line. If we needed to get it in slope-intercept form, right, then you would just distribute the negative 2/3, add the 2 to both sides, and get y by itself. Okay. But I'm going to stop right there because it just says an equation. That's an equation that has the point and the slope. Any questions on that one now? Again, the key here, whenever you see parallel, automatically think, I need the same slope. All right, perpendicular lines. Okay, so two lines with slopes M1 and M2 are perpendicular if and only if their slopes multiplied together gives you -1. Okay. Another way to say that is that their slopes are negative reciprocals or opposite reciprocals of one another. So basically, if one of the slopes is M2, then the other one is going to be -1 over M1. Now, horizontal lines and vertical lines are always perpendicular to each other. Now, let's talk about first, what does it mean for something to be perpendicular? So when I say perpendicular, what does that mean visually? Okay, they're going to intersect and they're going to form a 90-degree angle where they intersect, right? Okay, so that's why horizontal and vertical lines, right? If I have a vertical line and a horizontal line, they would form a 90-degree angle, right? So those would definitely be perpendicular, but I could also have like a line going like this, and then another line coming like this, right? And this right here would form a 90-degree angle. These lines would also be considered perpendicular to each other. Okay, so that's what we're talking about when we say perpendicular. Now, in terms of slopes, right? I know the formulas here can get a little messy. So let's just say that I have one slope. My M1 is 2/3. What would the slope of my perpendicular line need to be then? It's going to be -3/2. Good, because it's a negative reciprocal. So we're basically just changing the sign and then flipping the fraction, right? So 2/3 just becomes -3/2 if we're looking for a perpendicular line now. Now, if for some reason, you just have M1 equals like -3, what would be the slope of the perpendicular line? Positive 1/3, right? Because we could think of that as -3/1. Its reciprocal would be 1/3. Change the sign, it becomes positive. And so we get a positive 1/3 for the perpendicular line. So any questions about what we mean by negative reciprocals now to find the slopes of perpendicular lines? All right. So now we want to show that the points 3, 3, 8, 17, and 11, 5 are vertices of a right triangle. What we need to show then is that two of these sides are perpendicular and form a 90-degree angle, because that would make this a right triangle. First thing I'm going to do is I'm actually going to plot these points, right? So I can actually see what I'm looking at. So all of them are positive, so I'm only going to worry about the first quadrant here. So we have our x-axis and our y-axis. First point I have is 3, 3. So that's going to go 1, 2, 3, 1, 2, 3. I have a point right here. And so that's point P. My next point is 8, 17. So I got to go all the way over to 8, 4, 5, 6, 7, 8. And then I go all the way up to 17. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And so I'm coming up here. I'm going to have a point right up here now. And that's my point Q. All right, and then finally, the last point is at 11, 5. So I'm going to go over 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then I only want to go up 5. 1, 2, 3, 4, 5. It's going to give us a point right in here. Okay, and that's going to be point R. So what we're trying to prove here is that if I were to connect these and make a triangle, we want to prove that that's a right triangle. Now, looking at the picture that I've created there, where does it look like the right angle might be? Mine's not perfect, right? Because some of my spacing is not exact. It looks like R would be the most likely place for that right angle, right? So it looks like this could potentially be a right angle. So what I want to show is that this segment from P to R and this segment over here from Q to R are perpendicular to each other, right? If I can show that, then I know I have a right triangle. Well, that means I need to find the slope between Q and R and the slope between P and R. I'm looking for my slope here of Q and R, and I'm also going to find the slope of P and R. All right, so what's my formula going to look like if I'm looking for the slope between Q and R? What would the numerator look like? Okay, that's right. So we're going to use the y2 minus y1. And again, I'm looking at Q and R first, right? So I want to find the slope of that line segment. So what would the numerator piece be? And so what numbers would I use here? Okay, so it is going to be negative 12. So we're going to take 5 minus 17 or 17 minus 5, right? Whichever order you want to do that in is fine. And then if I do 5 minus 17, though, then what's the denominator going to look like if I subtract the x's here? Okay, right? So it's 11 minus 8. Okay, so just make sure whatever order you start with, you keep that same order, right? So if we do 5 minus 17 in the numerator, then we have to do 11 minus 8 in the denominator. Now, simplifying that, right, and we've already seen some of those answers. 5 minus 17 is negative 12. 11 minus 8 is going to give us 3. And so what would the slope of that line actually be then? Negative 4. Good. All right. Now, if that's the case, what do we need the slope of PR to be for these to be perpendicular? 1/4, right? So we're that we get 1/4 for the slope of the other line. So let's actually find it and make sure that it's equal to 1/4 now. So if we do P and R, what's the numerator going to be? Good. So 5 minus 3. And then the denominator would be 11 minus 3. That's going to give us 2 over 8. And what is 2 over 8? 1/4, right? So this does check out. Those are negative reciprocals of each other. Therefore, we know now that PR and QR are perpendicular. And so we do indeed have a right triangle this time. Any questions on what we did there? All right. So last example, we want to find an equation of a line that's perpendicular to the line 4x plus 6y plus 5 equals 0 and passes through the origin. All right, so what's the first thing we're going to need to do here? We need to find the slope. Good. And this right here, I believe, is the exact same equation that we did previously, right? So we subtract the 4x, subtract the 5. We end up with 6y equals negative 4x minus 5. Divide everything by 6. And so we end up with y equals negative 2/3 x minus 5 over 6. Okay, so that's the same equation we were looking at on the parallel line question, right? So we already said here this slope would be what? Negative 2/3. Now, if we want a perpendicular line, then what's the slope of our perpendicular line going to be? Good. We have to flip it and change the sign. So that's going to become a positive 3/2. All right, so now we know what slope we want to use. What else do we need to know to write this equation then? Okay, either the y-intercept or just what in general? We know the y at any point, right? So as long as we have a point and a slope, we can use point slope. If you specifically know the y-intercept, then we could use slope intercept, right? Now, what do we know about the point that this line has to pass through? 0, 0, right? Because the origin in this case would be the point 0, 0. So now it's up to you. That would actually be our y-intercept this time, right? Because 0, 0 would be where it crosses the y-axis. So you could just use slope-intercept, or if you want to use your point-slope form, it's going to give you the same thing, right? So it's up to you. If I do y minus y1 equals m times x minus x1, it's going to be y minus 0 equals 3 halves times x minus 0. Notice here, y minus 0 is just y. And if I distribute the 3 halves here, that's just going to give us 3 halves x, which is the exact same thing as y equals mx plus b, where b is 0 and our slope is 3 halves, right? So again, this form here or this form here, either one is fine. The first one tells you that it goes through 0, 0. The other one just tells you your y-intercept is 0. Any questions on finding the equation of that perpendicular line now? All right, so that's everything in chapter 1. Again, that practice test is posted, so if you want to start looking at that over the weekend, and then that way when we get to Monday, you'll kind of have an idea of which ones you have questions on. But I'm going to do my best to get through as much of that practice test on Monday as I can. The test will actually be posted midnight Monday night. You'll have 2 days to find a 2-hour window to sit down and take it. Again, if you have any questions about the test before you sit down to take it, please let me know. I'll be happy to answer those questions. Continue to send me questions on homework if you have them. Otherwise, have a great weekend, and I will see you all on Monday. All right, so